Hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be resuming working on those 4 monochrome CRTs. If you haven't seen that first part, I recommend you watch that first because this is a continuation of that part. I'll have a link in the description so you can click right to it. So without further ado, let's get right to it. A quick note before we get started. In this video, I'm going to be working on monitors while they're turned on and plugged in. There are potentially dangerous high voltages inside a monitor, especially when it's turned on, so please make sure you know what you're doing if you do any work like this. I want everyone to stay safe. In the last video, I took a look at the 4 monitors I'm working on and I gave them a subjective rating. I then opened them up to take a look at which were compatible with which when it came to tube swaps, and that's where we pick up now in part 2. So I want to start with the NEC, and the first thing to do is pull that CRT out of that chassis. I first start by removing the neck board from the back of the CRT by gently rocking it back and forth. Then I loosen the yoke and grab it with my hand and just twist, and that breaks the seal on it, and slide that off. And I'm using my high voltage probe to check for voltage stored on the CRT, and it discharges it at the same time. Once I'm sure it's discharged, I just unclip the high voltage anode cap from the CRT and pull it off. And take the 4 mounting screws off from around the CRT. And gently push up on the CRT from the front and lift it out. Make sure you don't lift it by the neck. It looks like I'm doing that here, but I'm actually supporting the CRT with my fingers. I put the old CRT aside and I have the new one here, and I'll just gently slide and place it into the chassis. Make sure it fits properly. It can be easier if you remove all the electronics, but in this case I was a bit lazy and I left them in. Lifting up on the CRT can help position it properly in the chassis, getting ready for the screws to be put back in. So I've only just started and I've already ran into a problem. And the mounting tabs are actually different. The entire band seems to be set a little further towards the back, so that leaves a gap all the way around on the monitor. It's not the end of the world because the mounting screws are long enough to go through into the case still. And really all I need to do is just find a couple washers so I can stick them under the mounting ears. So when I tighten this down, it's not going to put a ton of pressure on the implosion band, which is what these tabs are mounted to. I think what I want to do is just put the CRT in lightly with these without the washers. I'm just not going to tighten it down too much, just to hold the CRT in place, so that I can then mount up the deflection yoke, the tube socket, and connect the high voltage anode cap. I want to see this CRT working inside this monitor just to make sure this is actually better than the one that was in here, so that I'm not making this monitor worse. So I'm putting the screws in, making sure to not turn them too tight. That way I don't put that extra stress on the ears. Next up is the deflection yoke, which you just carefully slide over the CRT. We'll align it later. And then the neck board, which you just have to put on carefully. Take note of the pin orientation and the gap. And then the high voltage cap, you just clip on one side and just make sure it's on nice and firm. The one thing I want to check is the ground connection to the motherboard here. So this is the ground connection on this CRT, and there's only one connector. And on the other CRT, it had 2 pins that went onto these posts right here. And I just want to make sure that they're all common together so that I can plug this into any one of those and it will be okay. And yes, all of these pins here are exactly the same. So I can just put this onto any one of these and that is safe. All right, ready for testing. I turned the contrast and the brightness all the way down and I have my test pattern generator connected to the monitor. I don't have a computer hooked up to it. Let's turn it on, see what happens. All right, let's start by turning up the brightness. All right, there's a picture. Excellent. These convergence lines are crooked, if I turn the contrast up, and that's because the deflection yoke, I just randomly put it on without doing that carefully. How good is this CRT? This might be worse than the other. Unbelievable. Yep, I've tweaked the settings on the back of the monitor for the focus and whatnot, because the focus voltage can be a little bit different from one CRT to another. And it's sharp,
but it's pretty dim. The blooming, when you turn this up, the whole picture gets bigger. You see this? You see how the lines spread outward? And that's probably more to do with the power supply in the monitor as well, being maxed out and overdriven than the CRT itself. But if you turn it down so I don't see the raster, so I only see the convergence grid, this is definitely dimmer than the original CRT that was in this monitor. Boy, I just keep getting one bad CRT after another. I actually have a newer CRT tester on its way to me right now. It's in shipping. It's much newer than that one I have from the 60s, and it'll be great for testing the emissions on CRTs like this. And this one is so dim, I mean, it's not unusably dim, but it's definitely dim, that I would like to try the CRT restoring feature on there. And it has some really good guidance in the manual on how to do that, so we'll see when that thing comes what it'll be able to do. But at this point, this looks worse, and so this was definitely wasted effort. But as far as an experiment, well, it works. You can see the CRT is in here. It works, it fits. The bezel has all the right gaps. All I need to do is fix those washers on the back, and this would be a good CRT for this monitor. But the dimness, yeah, well, you know, I wish it were a little brighter, right? I also forgot to mention that this particular CRT, the one I just swapped in here, is an Orion brand, and it has pretty gross looking phosphor. When I turned it off, it's definitely darker looking than the lighter gray of the original one in here. That looked nicer. And yeah, this just doesn't look very nice. It's kind of that gross looking amber. I mean, it's still amber, and I'm probably being nitpicky here, but it's not nearly as pleasant looking as the original one, which had just a really delightful amber glow to it. I think what I'm gonna do is I'm gonna leave this CRT in this chassis for now, and I'll wait till I get my CRT tester, the new one that's coming. Then I'll be able to test the emissions on both of these. Whichever is worse, I'll do the rejuvenation on. I'll make a video about that, see if it improves the picture, etc., etc. But right now, both of these are so dim that I just don't really want to use this monitor. So let's move on to those two Philips monitors and try to swap the green and the amber CRTs around. On the bench, we have monitor number 2 and we have monitor number 3. These are both the Philips monitors. And when I look at these two monitors, I can really see the shared lineage of them. That this is the older of the two, with this one just being slightly more consolidated on the driver board here. Both these monitors use the same flyback transformer, and actually some of the other components look to be shared between the two of them. They both use a transformer to bring the mains voltage down to whatever, probably around 12 volts or something like that. And the CRT mounting mechanism, as I pointed out before, is the same on both. It uses these bands. The newer of the two monitors uses this Philips M31-344 LAPD picture tube. I know it's going to be hard to see that label because it's kind of behind the transformer. And it appears to have some writing on here, including maybe a little bit of Chinese kanji characters here. This monitor was assembled in Taiwan, so that's not unexpected. And on the other monitor, it's an M31-350 GHP. And I am finding it interesting that there is no Philips branding on here. It does say made in Taiwan for the picture tube itself, though. Looking at the PCB, it's interesting that there's a whole unpopulated section here. And I'm wondering if this monitor perhaps has a different variant that supported MDA, or the monochrome display adapter standard from IBM PCs. And that's what this section of the board was for. It looks like a DIP IC goes here and a bunch of other passives. So yeah, I'm pretty sure that that's probably what's going on here. The board on this monitor is physically larger, but it also appears to have a similar section that's unpopulated where a DIP IC goes. So I suppose this might have also supported a monochrome display adapter, and it's just not installed in this monitor either. Swapping the CRTs around is pretty much the same as any time. It's not much to it. Of course, I have the 70s psychedelic towel down to protect the monitor, and I'm connecting my high voltage probe to the DAG ground, and then I am sticking it underneath to discharge the CRT. There was no charge. And then using a flat blade screwdriver, I unclip the high voltage anode cap. And then I'm loosening the screw on the deflection yoke, and it has a little bit of paint on it, so you grab it with your whole hand just like before and twist it and gently slide it off. And I'm taking the screws off the brackets. I can only get to 3 of them on this monitor. The other one is behind the transformer, but that's fine.
and just lifting up on the CRT, the band kind of flips out of the way, and then I can just lift the CRT out pretty easily. I found the CRT to have a soldered wire on the implosion band, which I'm going to have to cut. Moving on to the other monitor, I'm just taking the 4 screws out, just like before. I'm just discharging the CRT like I did before on the other monitors, and I did find that none of these monitors had any stored charge, and they've all been off for about a day. And using a screwdriver just to remove the clip, just like all the others. Taking off the neck board. The deflection yoke has a little bit of paint on it, just like all the others, kind of holds it in place, so you just grab it, twist it, kind of crack the paint, and then you should be able to slide it right off. And lifting out the CRT. So this is the green CRT that I took out of the other monitor, and I'm going to get ready to put this into the nicer looking number 2 monitor. First, I'm going to give it a little bit of a clean because I like to clean it before I reinstall it. Just that any dirt that's on the screen that's hidden behind the bezel can get cleaned up because it might be hard to clean once the bezel is blocking it. I also like to clean on the inside as well because I'm weird that way. There ends up being a lot of soot and whatnot on the screen just from general use. So I like to try to clean that up just a little bit. You just want to do this lightly because you don't want to clean off that dull paint that you see all over the screen. That is the dag ground and is absolutely necessary for the CRT to operate properly. So just push very lightly if you're going to do this. All right, so I'm placing the metal band over the CRT and lifting it up and into the chassis gently. And just sort of like fiddle with the positioning and everything to kind of get it to fall into there properly. And yeah, it's in there. Now remember, I turned this around so the label is facing towards the PCB, and that's just so the high voltage anode cap would be on the same side as the flyback. So I'm starting to put these little clamp clip things, whatever they're called, that hold the band down to hold the CRT into place. You just want to put the screws in on these not too tight because you want to make a final pass once you have them all in to actually tighten the CRT down. So I'm just putting them on halfway. This particular monitor has 2 ground connections going to the CRT. One is on the clamp on the corner and the other one is down in the other corner and it goes to the PCB itself. Now I'm doing the final tightening of all the clamps, putting on the deflection yoke and the neck board. Because I have the CRT in 180 degrees, I had to flip the neck board around, which required a little bit of wrangling with the wires. And then the high voltage anode cap goes on to the CRT, and that's pretty easy because I turned it around so it's on the right side at least, but it probably would have worked the other way too. And the monitor is ready for testing, so just carefully flip that up onto its base. Okay, here we go. Is it gonna work or is it gonna blow? I have the test pattern generator hooked up, power lights on, so that's a good sign. I'm looking, I see the heater running. I did turn down the brightness and the contrast. Aha, look at that, it's working. All right, clearly the deflection yoke is out of alignment. All right, I'm having trouble turning the knobs. That's because the PCB is slid out a little bit. Let me turn this off. Oh, I can't even turn it off, okay. There we go. Okay, there I can turn the knobs now. Oh yeah, that is way brighter than it was. Let me just fix the deflection yoke there so it's aligned correctly. All right, well, hopefully the camera is in focus. I am just going to use this test pattern here to just give this CRT a little bit of an adjustment. Turn the focus control, for instance, and just make sure it's set up correctly because the CRT obviously is different than the last one it had, so its adjustments are probably not exactly the same. From an adjustment standpoint, most of the controls stick through the back of the monitor, like these 4 here, but there are 2 additional controls that are hidden on the screen, and one is the vertical linearity and one is the horizontal hold control, both of which probably should never be adjusted really that much, so it's good that they're actually hidden. And on this side, there are more hidden controls. We have the focus control, which on this CRT, this particular CRT at least, I have this turned all the way down. Then there's a sub brightness control, which I actually turned down as well. It was a little bit too high, meaning that the brightness knob on the front of the monitor has a little bit more range to it that's usable. And then there's a B+ voltage adjustment. B+ is like the system voltage that runs the entire
monitor, and you should never adjust that unless you have the service manual and it tells you how to adjust that properly. And I'm happy with these adjustments. I'm gonna put the back cover on. All right, so this one is good. Now time to put the other Philips monitor back together, the ugly duckling one.
Assembly here is just the same story. Carefully place the CRT on a mat. Don't want to break the neck off. And then I'm going to clean the front of it just to make sure there's none of that grime under the bezel. Place it gently into the chassis, making care to move that band around because, of course, I couldn't take it out due to that one screw that I couldn't access.
Well, I've reached a little bit of a problem. This CRT appears to be slightly bigger than the one that was originally in here, and it actually doesn't fit inside of these little holder things here. Hopefully you can just make out there are these little notches on here, and that's interfering with this copper implosion band here. So I think I'm gonna grab my snips and try to trim those away so I can fit this CRT into this chassis. Well, I got the CRT in there. I had to chop away all 4 of the corners, and it's mounted in there and it's fine. It's gonna stay in, it's not going anywhere. Now it's got that darker phosphor, so I guess that's an improvement. As I was putting together, I seem to have got a lot of marks on the front. My hands were pretty grubby from touching the CRT and pulling everything in and out of this thing. It really fought me. It really didn't want to take this CRT, but I forced the issue and it's in there. It might be a little bit hard to see, but there's a little bit of a gap right there in the curvature, so you can actually see down into the monitor. It's fine on the sides. I mean, there's maybe a tiny gap, but it's bigger right there, but whatever. So I think the question is, will this chassis accept this CRT? I'm sure it will, because the other one did, and let's turn it on. Well, we got the green light. Let's turn up the brightness and the contrast. Oh, there we go. Well, it's working, but it does look like crap. There's burning on this screen. The brightness is basically all the way up, and yep, the CRT, it's just a tired old CRT. And then we seem to have some kind of issues with the deflection up here. I'm not quite sure what's going on. That just could be one of the adjustments on the back. Let me fiddle with settings.
There's definitely a problem with the driver board in this CRT. Notice when I switch to crosshatch, the crosshatch itself expands upwards. I'm not going to bother try to fix it though. I just don't care enough about this monitor.
Well, I'd say it's adjusted as good as this one is going to get, so the cover goes back on. I just wanted to give a close-up look of how dirty this poor monitor is.
This poor thing is positively filthy. Not sure where this was stored because it's just so dirty. Look at the dust coming off of this as I tear it. Isn't that crazy? Inside the monitor, things aren't too dirty, and that's because the top cover had no vents in it, so there was no way for the dust to just fall inside and settle.
I've been trying to figure out who the manufacturer of this monitor is, and I think it's a company called Sampo. There is a Hitachi branded transistor right here, but the flyback and the deflection yoke are both branded Sampo. And I know Sampo was a computer monitor manufacturer back in this era, and I think they're still around today, although it might just be their brand name, because I think you can buy LCD TVs and stuff with Sampo branding, but there are definitely VGA monitors and stuff from earlier days that was also Sampo branded. The CRT is made by Clinton Taiwan Corporation, very big CRT manufacturer for computer monitors back in the day. I'm shining a flashlight on here. There are some numbers on the CRT. Don't really recognize them as part numbers. So if anyone else does, you can pause and read those. And just like all the other monitors, this has an isolated power supply. So the mains comes in, 12 volts or something to that effect, comes out and powers up the main board. But unlike the other monitors tonight, this one allows you to select between 120 volts and 220 by just moving this wire to the different tap here on the transformer. So that's kind of cool if you end up with one of these monitors in an international market and you want to run it off your local mains, you can just switch this wire. Although it has no tap for 240 volts, which I know is the much more common voltage these days in Europe. So I noticed this monitor, it does not use a CRT neck board, it just uses a socket and the wires are soldered right onto it. There's a spark gap right here. And they used electrical tape instead of zip ties. I see a few instances of that back here. There's more of it, which I guess works, but it's a little crappy. It makes the wires a little messy. Here's some more right here. And it's actually pretty much not holding on anymore. Okay, so I'm not swapping this picture tube out of here. I'm just going to take it out of the chassis so I can wash this front part because it is so filthy.
If you're disassembling one of these monitors, the first thing you have to do is pull off the two knobs on the front. And then I'm just doing the usual, like discharging the high voltage anode cap, and then removing it with a screwdriver to get the little clips off. You do have to remove the PCB to get the CRT out, so you gotta take these 4 screws off the bottom, which hold on the transformer, which is mounted onto a metal plate. Then the PCB and the transformer assembly just slides out of the chassis. Of course, you do have to remove the deflection yoke first. Now you can take out all the screws to remove the CRT. Once the screws are out, you can just lift the CRT out of the chassis.
So this is the mesh. It's held on a little plastic frame. So you could take this out and try to clean it, but again, I don't like these because you have to drive the CRT so hard to see the picture with good brightness. So it's best just to take these out, even if they're not that dirty. That's my opinion, at least. And hopefully you can get a view of how filthy the monitor is behind that screen. That's because it's never really been cleaned its entire life. So it's a desperate need of a clean. There's a clean spot in the middle here where I cleaned it, but it's not clean anywhere else under there, and it's pretty caked on. It'll clean right off, but I mean, this is pretty bad. All right, now to the sink to give this thing a wash. The back I already cleaned. Now that is a transformation. Look at that thing. It's like night and day how this looks now. It actually, I wouldn't say this is mint condition, but this monitor is in excellent condition, at least from a physical standpoint on the outside. Time to give the CRT a nice clean on the front of it. Oh, I'm running out of Windex here. Prepare for a lot of dirt to come off on this cloth, or this paper towel, I'd rather say. I was gonna say, does it have burn-in? No, it's just the dirt that's on the monitor. Yep, that was dirty. And because it's what I do, I just like to clean this part of the CRT as well. That is one black paper towel.
Reinstallation of all the parts is pretty straightforward. It's just reverse of what you did taking it out. After placing the CRT in the chassis, you can just reinsert the screws. You do just 3 of them because one of them is the ground lead to the PCB. So you have to do that after the PCB is slid in. What I'm doing here is I'm putting deoxide on the front controls, those potentiometers that were scratchy, and I'm just moving them back and forth quite a bit. You slide the PCB and the transformer board into the chassis together, and then now that the ground lead reaches, you do have to screw in that one corner with the little metal fingers that touches the DAG ground on the CRT. And then I am attaching the front control panel, which has a little PCB and 2 screws, onto the plastic front. There's also a little board with an LED you have to reinstall. And then you install the deflection yoke back onto the CRT. We'll do the final alignment later. And of course, reinstall the high voltage anode cap, making sure it fully clips in and is secure. And I'm putting some deoxide on the rear potentiometer controls and then moving them back and forth fully through their motion. They were a little scratchy and I want those to work perfectly. And I'm doing a final air dust, give it the final clean to make this thing look as good as possible on the inside.
So that is one clean CRT. It's looking really good in here. Very little dirt or anything like that. Just a little bit of dust here and there on the capacitors. But overall, this thing is really clean and hopefully it works well. Can't forget to clean the cord because this thing is really dirty. I was about to plug it in and I realized that if I touch the cord, I would be getting dirty hands, which I don't want to do. And that is much better. No more dirty hands, just touching it. All right, test pattern generator is connected. Here we go, pull to turn on. I like that light. It's just so dim, the little amber light there. All right, well, we have raster and unfortunately, burn-in. I just can't catch a break with these amber monitors. There is that horrible burn-in, some kind of a status bar. Whatever program this thing ran a lot of burned in this status bar there, and I can just see faint burn in from the lines of text as well. It's probably not coming across in the camera. So first I'm just going to turn this yoke.
And now it's all about adjusting the monitor. I basically try to get the picture as centered as possible, and this crosshatch pattern really does help. A lot of monitors have a way to adjust the horizontal and vertical size by adjusting the coils. And then to actually move the picture around, you have to adjust the magnetic rings that are on the deflection yoke. And I do that while the picture is shrunk, and then I expand it back up to have more overscan again. Of course, different 8-bit computers have different centering on the screen, so sometimes you adjust it for what you think is centered and then you boot up the Apple II and it looks completely off center.
So after much fiddling, it turns out that this CRT is quite worn out, which makes sense because of that burn in that we see there. And with the brightness turned all the way up on here, it just wasn't very bright. So I actually had to turn up the sub brightness on here, and now it's definitely a little better, but it's still not great. It should do though, because this monitor looks physically really nice, but it definitely could do with a replacement Amber CRT, the one that's not nearly as worn out as this one. Okay, on the bench, I have all of the CRTs in the original order from 1, 2, 3, and 4, and there's now an extra number 5 monitor, which I'll get to in just a second. The number 1 NEC monitor here, I just ended up reverting it back to its original CRT. So in the end, I didn't actually do anything to it, well, other than waste time by putting that other CRT that was worse in it, and then going back to the original one. If anything, I cleaned this CRT under the bezel, so that's a bonus, I guess, but yeah, otherwise it's exactly the same. As you already saw, the number 2 monitor, the nice boxy Philips, ended up with the green CRT that came out of the number 3 chassis, and it works really, really well. Looking at 80-column text over composite from the Apple IIc, things are really just looking quite good for this green CRT in this particular chassis. It looks really nice. There is room for a little bit more sharpness on the text, and I'm going to try to address that actually with a little bit of a mod to the board in this monitor. But overall, I'm very, very happy with this. The only thing that is slightly let down, and that's by the CRT itself, is if you notice around the cursor, there's a little bit of blooming. I don't know, the light is not super sharp, and is not the driver board, is not the phosphorus, none of those things. It's actually a physical manifestation. The glass on this CRT has been etched to make it kind of have an anti-glare coating to it. But that unfortunately has the side effect of diffusing the light slightly, so that the green light coming off the phosphor, it just is slightly blurred, and that is that anti-glare coating. And unfortunately, there's just really no way to fix that. But the reality is, it's not a big deal, and it still looks pretty good. It's just really nice to have a nice, sharp, bright image on here that has no burn-in.
In order to improve the sharpness even further on this monitor, I found the schematics online, and what you see here is the cathode drive circuit. And by replacing a 27 picofarad cap with a 330 and removing a resistor, I just jumped it, that improved the edge sharpness considerably on this monitor. I also went ahead and I replaced the orange LED with the green LED. And for some bonus footage, here is some slow motion footage of what it looks like when you turn off this CRT. The raster collapsing like this drains the high voltage from the CRT.
The number 3 chassis monitor here, which ended up with the amber monitor from this boxy one, really doesn't work very well. There are problems with the original chassis, with the electronics, and the CRT itself is just worn out and crappy, but there's actually another problem. Besides that bottom gap in the CRT, which I already mentioned because this CRT doesn't fit well in this chassis, when I went to put this thing back together again, I noticed I couldn't get this back cover on, and there's a reason. The original green CRT that was in this chassis had the high voltage anode connection here over on the side, and the amber one I put in here has the connection on the top. Well, unfortunately on the back cover, it has a carry handle, which necessitates this indentation inside the case. And guess what? This indentation hits the anode cap because this whole thing is relatively compact. So I can't actually put this back cover on anymore. And yeah, I could probably cut away some of the case here, but that would be dangerous because if the thing were running and you went to put your hand in here, you would basically be putting your fingers right on top of this high voltage anode cap. So unfortunately, because this monitor I find really ugly, this CRT doesn't fit in here, and the CRT is really worn out, and I can't even put the back cover on, so it's not like this thing can even really be usable. I am relegating this monitor to be spare parts. I have several monitor PCBs and other parts from monitors that I just keep around in a box because you never know when I'm going to need like a flyback transformer for a different monitor, or some other component that's on here that's still totally good, I can just steal it off this board and stick it on something else, like save another monitor with parts from this thing. The Amdek 300A, it just cleaned up and actually looks like $1 million. The only thing, of course, that's slightly letting it down is the CRT isn't as bright as it should be, and there is a little bit of burn-in on the bottom. But ultimately, when you use this monitor, it still looks quite good. I really couldn't be happier with this thing. I cannot believe the state that it was in when I got it and how good this thing looks now. 80 column text on the Amdek 300A, it just looks great. I mean, it's not the best, it certainly could be better, but this CRT is in decent shape once it had a good cleaning and adjustment on the monitor, focus control, stuff like that. I'm very, very pleased. And luckily the burn-in is just not terribly noticeable. It is only on that one line down at the bottom there. And overall, this thing is just a joy to look at, especially because the monitor itself is in such good shape. So this brings me to this Amdek monitor, which I haven't shown yet in this whole video series. This was actually an Amdek monitor I already had. It's a 310A, which means it's a monochrome display adapter version. It's not composite like the one I was just showing. I'd acquired this monitor originally when I picked up an old PC a few years ago, and this was just bundled with it. I like these Amdek monitors a lot, which is why I held on to this one, but this one had really, really bad burn-in on the original CRT. I am calling this monitor the number 5 monitor, but if you remember early on in the video, I had the 4 original monitors, but I also had an extra CRT that I had taken out of a different monitor. Well, I saw that monitor and I thought, you know what, this should work well in here because the mounting tabs look completely compatible. And sure enough, I took this apart, I yanked out the old CRT, which incidentally is exactly the same CRT that's in the 300A. These monitors are basically identical inside, with the exception of a little bit of component differences on the main PCB. And of course, this has a DB9 input, while the other one has a composite. But yeah, this was the CRT that I originally had stuck into the NEC monitor and was unhappy with it. In that monitor, I judged this CRT to be a 4 out of 10. But in this chassis, it actually works a little bit better after I calibrated and tuned the settings, and I'm giving this a 5 out of 10 in here, which is a marked improvement from the original CRT in here, which is this CRT right here. Now, I'm not sure if the camera is picking it up, but even when this thing is off, you can see exactly where this thing was used heavily, and the burn-in from all the lines of text that this thing had experienced over the years, it's just really not great. This Amdek 310A isn't in as good condition as the 300A. There are some scratches on this front painted bezel, which I actually drew over with a little Sharpie because they were white and didn't look so great. So that looks a bit better now. In addition, there's quite a bit more yellowing on this case than the other one. I mean, it doesn't look horrible, but it definitely probably could use some retro bright. And on the back, of course, this has an IEC input for power, and it has the 9-pin connection for the monochrome signal that goes into the same 2 places as on the other monitor. Looking at text on the 310A, it is relatively sharp. Now, this is dim monochrome text, because there's a bright and a dim. But unfortunately, having compared this to the 300A, which we just looked at a second ago, this is so significantly dimmer than that one. In fact, the camera's exposure is fixed to the same exposure level I had just a moment ago on the 300A, and it looks a lot dimmer in the camera, I'm sure, because it certainly does in the viewfinder. Launching Check It gives us a view of the bright text versus the dim text. And if I adjust the contrast knob, I can actually make the dim text disappear completely, because the way this monitor is wired up is exactly the same as the IBM 5151, where the brightness control controls the overall picture and the light text, and the contrast controls the dim text. So I can turn it all the way up, and I can make the dim text exactly as bright as the bright text, which is the words here. But if I turn it down, you see that you can create different 2 tones. The MDA standard has more vertical lines than does regular NTSC. I think it's got 300 or might be 350. So the scan lines are closer together. And that means that if any kind of blooming happens, they will become more indistinct. And it looks like in the bright text, that is happening on this monitor. Even with that, text is completely readable, and it just seems like this CRT is performing better in this Amdek monitor than it was in the NEC chassis when I first tried it. Unfortunately, I don't have any footage from this monitor before I swapped the CRT, so we can't even compare it. But I can tell you that besides the burn-in, this CRT is definitely a lot brighter, and it makes me really pleased with this monitor. I'm very happy. I wish it were better, but nonetheless, it still works well. And monochrome monitors, MDA monitors, just not super common anymore. So I'm glad to have a nice working example of a 310A, even if it's not perfect. So in the end, the big question is, was all this work I just did actually worth it? And I'm going to say yes, yes it was. I'm really happy with the way these 3 monitors turned out, and yes, none of them are actually perfect, but they work a lot better than I feel that they did originally when I first started, and I can use these nice CRT specimens on the matching appropriate computers. I really feel that monochrome monitors have their place on retro computers. You can of course use a color monitor with an Apple II, but it just doesn't look as good in a lot of situations, especially with all the color fringing you get on text. And these monitors don't exhibit that problem, and they give you an incredibly sharp image all the time. And that's what I really like about them. Not to mention the nostalgia factor of the beautiful amber glow of the amber screens, and I also have nostalgia for the green screen as well. As I had mentioned earlier, I've ordered a new CRT tester, and that should be coming soon. So you may see these monitors again when I get that thing and I decide to hook it up and potentially try improving these monitors a little bit, or at least improving the ones that aren't working as well, like the NEC monitor and that other Philips one that I've taken apart and won't put back together. Those are good guinea pigs because I'm not so worried about making them worse, which is always a risk when you use the Rejuvenator. Anyway, I hope you enjoyed this video. If you did, I'd appreciate a thumbs up, but if you didn't, you know what to do. Hit that subscribe button to subscribe to my channel, and of course the bell icon for notifications. And of course, put your comments and your suggestions in the comment section below. And that's going to be it. Stay healthy, stay safe, and I'll see you next time. Goodbye.